Hello guys, and welcome back. And welcome back to a video about the current setup and current situation with this build, the EV build. Basically, we are in a situation at the back of the car where we're almost complete. There's obviously some tidying up bits and pieces to be done, but the lower battery box at the back is done, the upper battery box is done. I have it connected. There's a relay, in a small relay in that white box, which is being driven by the ignition, and when the ignition is turned on, that relay kicks in, sends 12 volts to these. Let me get rid of that. Sends 12 volts to these two contactors and turns them on, and that activates the rear battery box to allow the power to go to the front of the car. Now at the moment there are a couple of the connectors which are not in place, which means that nothing goes live whenever I put on the ignition. Apart from those two connections, everything else here is good to go. I have the cable, as you can see, going down through the back of the car, and hopefully we'll be able to get a view of it. It'll probably be a bit dark under there, but as you can see, the cable's coming down there and go along to the front of the car. Yeah. Right guys, well, as you can see, we're at the front of the car this time, and we have the alternator motor for the power steering pump, and the power steering pump mounted, and we'll have the belt on, so I can spin that like so. So that should be relatively simple to get going. All I need to do is put an Ebike controller on that, 36 volt battery, and Bob's your uncle. That's really simple. So that's okay, I'm happy with that. I'm now trying to figure out how I'm going to bring the positive from the back battery box and feed it into this front battery box. Now, there's a couple of ways I can do this. I can either feed it straight into here, into this battery box, and which means it'll come up to the high voltage junction box, just through a hole in the lid. So we can do it that way, or I can feed it into this box. Put it to one end of these batteries. I'm hemming and hawing as to how to do this. I'm really not sure what the best way to do it is. It might, just thinking about it, it might be best just to take the pause from the back of the car straight into the high voltage junction box. That way it'll be nice and easy to control. I can put there's going to be a contactor on that anyway. I have to put a second contactor in. I think. Not sure what the best way is to do this. But this is getting to the stage now where it's all final positions of everything and hooking up the high voltage cables to it. So that's where I'm starting to struggle to make my mind up as to how to do it. But I shall make a decision and come back to you when I've done that. This cable is the 240 volts coming from the charger, from the charger connector there, and the positive of the high voltage cables comes up here and goes into this box. I can get my head out of the way. Goes into that box here and goes down and joins on to the front battery box down here. It then goes joins a negative on a battery there, so it goes negative pause, comes up, negative pause, and comes up to here. And when we get the connections made, this will be the final positive from this pack and the rear pack. And now we'll just bring that into the high voltage junction box and join it up with these two wires, which will be coming up from this battery box. So still quite a few connections to be made. I still need to cut a hole in the bottom of this box and a hole in the top of the battery box so that I can bring these connections up. So that's where we are at the moment. So the next step, I guess, is to sort out this lid and get the battery box, get the high voltage junction box onto the lid of this battery box, and then take it from there. As you can see, this is all secured with M8 threaded rod, and all these modules are all secured and connected at the front. So we're getting very close to having the whole thing going live and properly live with just a turn of the key switch. As you can see, I have been doing some testing here. A lot of these connections are still quite loose, deliberately so, because the cables are not I haven't actually cut the cables 100% correctly to length yet, because at the moment everything is still I'm still a bit uncertain as to how I'm going to route them under the car. So that's why things are not 100% connected. This is just a 12 volt battery that I was using for testing purposes. I'm trying not to short them out. And as you can see, I've put in it's actually a solar fuse. What I'm slightly concerned about is the cables that go out to the battery charger under here are sitting at 300 volts, but this is the cable going out, and as you can see, they're really quite light cables. They're only 3 or 4 millimeters square, something like that. So the idea of having those fused at 400 amps did not appeal. So this is how I'm putting, I think, 10 amp fuses in here, just to try and make the cable going through here and down to the charger a little bit safer. As the great man Damien Maguire says, fuses are to protect your cables, not your electronics. Purely to stop the cables going in fire. Now, this is how I've been timing the pre-charge and the main contactor and the secondary contactor. I've been using these little timer modules to do that. However, I've found them to be slightly well, not the most reliable as far as the timing is concerned. And for me, the timing for this whole thing is absolutely critical. I cannot afford to have the pause and neg go into the main through the main contactor at the same time as going through the resistor. If that was to happen, if it was to lose the correct timing, it would damage these contactors. They would end up being fused. So what you have to do is trigger your 300 volts so that it goes through a resistor first to here, and after a second or two of the voltage building up gradually through the resistor, you then trigger the main contactor, which allows the voltage to go straight across the contactor. That timing wasn't working properly with these two timer modules. So to try and sort that out, I've got this. what this is, get this out of the way. What this is a timer module, sorry, a relay module, which is controlled by an Arduino. Now what I've done is I've set up a little sketch in the Arduino which triggers these relays in a certain sequence, and I'm now going to get that connected up so that we can show the or see the relays switching on the contactors with the appropriate timing. Now to do this, I'm going to use a voltage buck boost voltage regulator. I'm a little concerned, okay, scratch that, I'm a lot concerned that the 14 volts coming out of the charger would damage this and could potentially cause these things to be running at a very high current. So what I'm going to do is try and run those from 10 volts, which would be perfect for the Arduino as well. And the Arduino is supplying the relay block, so 10 volts should be fine for this whole thing. So I'm going to try and get that set up now, and I'll bring it back when I have. Alright guys, I know this looks like a bit of a mess, but it's just a quick setup to do the testing. And what I've got going on here is this is a small 12 volt battery feeding through this switch into this buck converter as constant voltage, constant current voltage converter. So it's converting down from 12 volts down to 10 volts, and I have a little voltmeter there so that we can see the voltage. I have the Arduino with a feed going into it so that as soon as I flick this switch, it powers on the Arduino, and the Arduino will then control the switch block or the relay block in a particular sequence, and we'll go through that when I go to first turn it on. What I have at the moment is the multimeter is sitting on ohms range and is sitting across the main contactor. Now at this point in time, this contactor is not, if I can just show you, is not connected, and the reason for that is I want to see, in this first test, I want to see the resistor going across that contactor initially, and then after about 6 seconds or 5 or 6 seconds then turning off. So what should happen is I should flick this switch, and once the Arduino powers on, it should trigger the relays, and initially it'll trigger it so that the negative relay and the positive relay come on. The positive relay does not come on. I have it disconnected at this point, just for, you'll see when I actually do it what happens. But it should initially put on the pre-charge resistor and on for several seconds and then off. So let's flick the switch and see what happens. Okay, you can see the Arduino is starting to kick in. You can see the voltage is at 10 volts, and we were too slow to see that, so we'll just do it again and turn everything off. Okay, so it's open circuit at the moment across the main contactor. As soon as I click that switch, it goes to 30 ohms, which is what we want. And then it goes, after a few seconds, it goes open circuit. So what I'll do now is I'll plug in the contactor again, so that it's actually now going to go part of the circuit. So what should happen now is it should go on at 30 ohms initially, and then about 3 seconds later it should then go to 0 ohms because the main contactor will kick in at that point. Okay, there we go. It's gone to 30 ohms. Now it's gone to 0 ohms, and now that's the resistor being removed from the circuit. So that seems to be working correctly. So the point of all this is so that the resistor comes in first to put the 300 volts into the inverter. The The reason for that is there's large capacitors in the inverter, and if you were to just to put 300 volts or 400 volts through a switch directly into the inverter, there would be a massive inrush of current, which would be enough to destroy the contactors. So what you have to do first is to gently feed the current in through a resistor just till the capacitors get charged up. It only takes a second or two, and then you can flick on the main contactor, which gives you it's just the main connection to the inverter, and at that point you can then remove the resistor. It's always good practice to remove the resistor, because I believe anyway, I'm not 100% sure, good practice to remove the resistor so that it doesn't burn out over time. So anyway, that's the positive contactor. We can see what's happening there, the way the resistor is coming in first. I'll just turn it off again. The negative contactor should, if we can jam that in there, negative contactor should come on instantly as soon as we click the switch. So hopefully, right, so as soon as I click this switch, that should go short circuit. At least maybe it would do if we had the proper connection. We'll try it again. There we go. So immediately that goes short circuit, and then stays short circuit for the entire duration. So you have a constant negative. But as you can see, we've got 10 volts, and which is very nice. And what I'll do is I'll flick this over to current. I'll push the button to make it DC current, and then we'll try and see what the current is. So the total current is, as we can see there, it's 1 amp. So we're getting 1 amp at 10 volts, which means half an amp at 10 volts each. Well, that's powering the entire system, so there's obviously less than that powering the two contactors, because they're both, they should both be short circuit at the moment and getting power. So because I've reduced the voltage down to 10 volts, it was partly for controlling the Uno, but it's also to lower the current going through these contactors, because the voltage, the normal voltage coming out of the charger and from the normal 12 volt battery will be around 14 volts, and at that voltage the current going through the contactors was about 600 or 700 milliamps, and by doing what we've done, it should reduce it down quite significantly. If we're going to be able to check that or not, there's one of the leads. Yep, it looks like we're getting about 200 milliamps now, as or 250 milliamps is going into the contactor. So that is okay. I'm happy with that. That's, like I say, significantly less than we were drawing at 14 volts. And the contactors seem happy enough running at 10 volts, so I'm not going to worry myself about that. So anyway, guys, that's where we are with this. I'm now going to do the scary thing and get everything wired up properly, connected properly, put the full 300 volts from the main battery pack and these batteries into the high voltage junction box, and we're going to do some testing. Alright guys, well, as you can see, we've now got the main battery in place, and I have wired this whole contraption from a switch 12 volts. This is coming as switched by the ignition, so as soon as I turn the key in the ignition, I'll get 12 volts through here, and into our little voltage reducer. It'll then come out of that as 10 volts and into this slot. Hopefully you should see this resistance going from open circuit to 30 ohms and then to short circuit. So I'll put you up on a stand, go and turn the ignition on and see what happens. There you go, 30 ohms and then short circuit. That's exactly what we wanted. And then the last click is the resistor being disconnected from the circuit. Right guys, this is where it starts getting scary. As you can see, that connection has now been made, as has that one. So this battery pack at the back of the car is completely connected, and when I turn the ignition on, these two contactors will kick in and send all of the power, all of the voltage from this pack and the one below it through to the front of the car. So let's go there. So as you can see, I've got the negative of the battery pack. This is the main battery pack negative, disconnected from the contactor, simply because I want to confirm that we're getting the full voltage plus the correct polarity before we put the power through to the inverter, the voltage through to the inverter. So I'll stick you onto the stand and go and turn the key. What should happen is the contactors in the back of the car should click in and send the voltage through to this front pack, and then the front pack is connected directly up into the negative is connected directly up into there. Sorry, the negative from the back of the car goes directly into there. The positive from the front, from the back pack, goes into this pack, and then through and into the high voltage junction box. So whenever I turn on the ignition, contactors at the back should kick in, and this should see 350 volts or thereabouts. So here's hoping. Ignition on. There you go. Contactors at the back of the car kicked in, and we got 350 volts straight away. So now I can turn it off. That'll kill the two contactors at the back, and that should turn it off again. And just for confirmation, it is showing the correct polarity. Taking nothing for granted. Right, so that's the ignition off. There's no volts there now, so I can safely hook this up to the contactors, and that will put the full battery voltage to the inverter and the inverter and the charger. Okay, well that's it, reconnected. So now whenever I turn the ignition on, the 350 volts will come now through to this point and also go through this contactor. Alright, so we now have 350 volts through to the inverter and charger. Good. Nothing went bang. The magic smoke is still in. I guess the next step is to reconnect the VCU and get that operational. We can drive it. And also, probably shouldn't do it, but I will. If I disconnect this connection here, the Arduino should lose its voltage and turn off these two contactors. There we go. So as soon as I lift that up, it should break that circuit, and there you go, we're seeing the voltage dissipating slowly. So I'll go and turn it off now at the ignition. That's it, turn back off. We'll not plug anything in just yet because there's still quite a high voltage there. It's just getting the voltage through from the inverter. The voltage is still dropping down. Although I had broken the circuit of the tamper switch, the main connections were still there, were still live. But that just proves that if anybody tampers with this, if you try to take this off live, it'll kill the power. That's good. There's a few other safety measures we still have to put into place. I need to make sure the anti-tamper at the back is connected to the anti-tamper at the front, so that when either is disconnected, both sets of contactors will automatically turn off. And it would also be better if they did not turn back on again when it's pushed back in. You had to actually turn the key off and back on again. So things like that still to be sorted out, but we're getting there. Baby steps. Anyway, that's it. Operational at this stage. We just need to get the 2 or 3 things going, and this car will be drivable. So, on that bombshell, thanks for watching, and bye for now.